So, dear students, back once again with you in this class of relative motion. So, again, I am discussing this very important concept which I discussed in the previous video also, but then we just took constant velocity in that question, the illustration that I dealt, I mean to say. अब हम ये देख रहे हैं कि अगर एक पार्टिकल दूसरे के रेस्पेक्ट में एक रिलेटिव वेलोसिटी भी है और एक्सीलेशन भी है तो क्या होगा. तो सबसे पहले मैं आपको फर्स्ट ऑफ ऑल आई शुड टेल यू दैट वी शुड नेवर मिक्स अप द टू थिंग्स, दैट इज रिलेटिव वेलोसिटी एंड रिलेटिव एक्सीलेशन. दीज आर टू इंटायरली डिफरेंट थिंग्स which we often mess up. Now a particle can have zero velocity and acceleration, something which confuses it. For example, if I drop a pen, it has no velocity initially, but it has an acceleration g. So relative acceleration of two objects, relative velocities of two objects, these are two entirely different concepts. It is possible that two objects may be at rest with respect to each other and still accelerated. So you will be surprised, how can it happen? They are at rest. I can tell you, there are two cars which are moving in the same direction. Just think of this. They are moving with same speed. What is their relative velocity? Zero. But maybe this is increasing its speed. It has pushed up the accelerator, so it's increasing its speed, and at this moment it's not increasing its speed. So at this moment, what we can say is the two are relatively at rest, but their relative acceleration is not zero, because this is accelerating. Now of course, after some time its velocity will change, so their relative velocity will also not be zero after some time. But at this moment, when it has started accelerating and this is not accelerating, the relative velocity is zero, but relative acceleration is not zero. So never mess up the two things. Now here I have written velocity of A with respect to B equals to VA minus VB. This means velocity of A in ground frame, velocity of B in ground frame. This frame word often confuses it. In physics sometimes there are big words which become confusing. Ground frame means like with respect to a stationary observer on road who is standing still and watching some car. When you say this car has a velocity VA, then you are saying, oh, this car is moving with respect to me with this speed. Another car is moving with some other speed. But if an observer in car A is observing another car B, an observer in car A is observing car B, then that means velocity of B with respect to A. Here I have written A with respect to B. You can also say B with respect to A, and I told you they are negative of each other. Now this is acceleration of A with respect to B, which is acceleration of A minus acceleration of B. So these are two different things. Now you can see I have written here one equation of motion, that is S is equal to ut plus half at square. And you can see another equation, S relative, U relative, A relative. So you will be confused what is all this once again. Physics has a lot of avenues for creating confusion for people. Why physics is felt difficult? Just for a moment I take a leaf from there. Physics is the science of logic, is the science of thinking. And this is something that we are lacking in. The whole world is lacking in the power of thinking. We don't know what thinking is. We can borrow thoughts, we can mug up things, but we don't want to apply our brains. And this is something which was told to me 30 years back by an eminent professor, like who was Professor G.N. Subramaniam. He told me this great thing, that we don't want to think. So can you put some pressure on your heads? Then only you can learn physics. If you want to take an easy ride, then the ride is not so easy with physics. So like the concepts like this, I have written relative. Now see, there are two cars, A and B. This is moving with 2, this is moving with 8. Now these are speeds. So there is a difference between speed and velocity. Now suppose I ask you to write the velocity of A, what will you say? 2 meters per second, very good. Write the velocity of B. Sir, that is 8 meters per second. You are wrong there. This is not 8. Can you see the direction of this? The speed is 8, that is fine. But when I am writing velocity of B, I should put a negative sign. and this is where we miss upon our problems. This is minus, because this direction is this and this direction is this. So this, if this is plus, this will be minus. But with acceleration, I have already given sign as +2 and -4, so that there is no confusion later on. Second question. Now this acceleration is negative. Small points we will touch. Does it mean that this car is retarding? Is it decreasing its speed? Yes, sir, this is decreasing its speed. Again, you are wrong. When an object decreases its speed, in my videos, you will get to learn many small things which people often miss when they discuss. So, when velocity and acceleration have same sign, can you see minus and minus? Then their speed is not decreasing but increasing. When here, for example, it is +2 and +2, speed is increasing. -8 and -4, speed is increasing. So if the velocity is in this direction and acceleration is also in this direction, that is, both are negative, that means this car is increasing its speed in this direction. Here also this is positive and this is also positive, means it's increasing its speed in that direction. So don't judge just by the sign of acceleration. See what the sign of velocity is. If this sign is negative and this is positive, suppose this is positive, that means it's decreasing its speed or retarding. This is one thing. Now second thing is, the question is, if these two cars are at a distance of 100 meter, I have shown very big. Actually, if 100 meter is a large distance and car is a small thing, so it would be like these 2 points almost, which are separated by a 100 meter, not that big, but for your clarity I have drawn big cars and this distance as 100 meters. Now I am interested to know if an accident is going to happen or not, and that is very much going to happen unless any one of them applies brakes. Suppose they don't apply brakes, unfortunately I don't want that, but suppose it happens, what will happen? An accident. So when will that accident happen and where will it happen? This becomes a question in physics once again. That's what you call a problem. When you send me those messages, sir, we can't solve problems, that is the kind of problems that you face. So can I use this? No. Can I use this? Yes. Now relative to what? So you choose. Can you tell me, should I choose A or B? I choose B. So I will consider the motion of A with respect to B. So I will say x displacement relative means displacement of A with respect to B. Initial velocity of A with respect to B into T. This is the equation which I am applying now. Just see here. For relative, I am taking everything with respect to B, and I told you when I am taking with respect to B, that means you freeze B. Whenever in relative motion you take a quantity with respect to some other thing, then just freeze that some other thing, just freeze it. So I am freezing B. So this will become half A acceleration of A with respect to B into T square. Now just think that if an accident or collision is going to happen, where will it happen? I don't know. When will it happen? I don't know. But I know one thing, that this will happen here. This car will come and strike all the way B. You will say, no sir, you are wrong, this will not happen, both of them are moving, sir, this will not happen. That's what you say. I know your kind of doubt. Sir, both are moving, why are you saying this will go all the way? And but dear, where are we taking, what are we taking here? We are taking with respect to B. I said just freeze it. That is the secret of relative motion. Freeze the object with respect to which you are looking. If I freeze it, then this car has to come and hit it all the way. If I freeze this has to come and hit it. So I am taking with respect to B. With respect to B, A will come all the way here. So its displacement as AB will be 100 meters. Do you agree with me? Actually, this will not happen. So we will see actually what happens. But with respect to B, it comes all the way to 100. With respect to B, its velocity is UA minus UB. Look carefully. UA minus UB is how much? Sir, UA minus UB is 2 minus 8 minus 6. Wrong. UA minus UB. 2 minus 8 is 10. Our brains have rusted these days. I often find students' brain rusted. It's written 2 minus fade, and still they say it's minus 6. This is 10 plus 10. So that is 10 into t. Now acceleration of A with respect to B. So 2 minus 4, that is 6 t square. Wonderful quadratic equation. 3t square plus 10t minus 100 equals to 0. Can you solve this? Let me try to solve. I often make mistakes also. Not that you only make mistake. So I do mentally minus 10. You can use your method. Root of 1300. Sometimes I calculate fast. B square minus 4ac I have done. Upon 6. So minus 10. I have not taken minus sign here because time cannot be negative. It will be positive. So plus 10 root of 13 upon 6. Okay, so root of 13 is not 3, it's not 4. 3 is a 9. So it may be 3.5, let me take approximately. So approximate answer I am taking. You can calculate the exact one. So it says 335 minus 10, 25 and 6, that is 4.1 second. You can calculate the exact. It may be 4.2 or 4 point something. So this is the time in which this collision is going to happen. But where is this collision going to happen? Now, in the first place, you should appreciate that by using relative motion, we have found time. So that is the beauty of relative motion. It can give you time easily. The time in all relative questions can come very easily. But if asked where, then it's another question. So now see, for relative motion, I said this strikes all the way here. But this is not the truth, you also know. Collision may happen somewhere here, for example. Both of them, they come here and collide. So now we again shift our gear to the actual motion of A to find where. Now we shift our gear to the actual motion of one of these to find where the collision is happening. So we went to relative, now we are coming to the actual once again. So now we won't write relative equation, we will write SA equals to UA plus half UA into T plus half AA into T square. Okay, half AA into T square. We will use this equation for A. Now see where the car goes in this time. This time is relative, time is not relative, time is actual, but displacement is separate. Time is the same for both, isn't it? If you walk and I walk, then both of us, if they are colliding, they are taking the same time. But now I am not considering relative, I am considering the actual motion of A in this same time. So that will be UA, that is 2 into this time, whatever it is, plus half into acceleration of A, which is once again 2 into time square. So it is 2t plus t square. So t square may be something 16 plus 4. So it is this answer is somewhat greater than, I am not calculating it exactly, 20 meter. Like my calculation is rather more than 24 meter, I should say, because 2 4s are 8, 24, more than 24. So this collision will happen somewhere at this distance from A. How much distance? 24 meter. And if you want to find this distance from B to this, it will be 100 minus 24, that is 76 meters. So actually you can see the collision happening near to A, and that is logical also. Why? Because it has small speed and small acceleration. It has large speed and large acceleration, so it will come farther, it will come nearer. So here it will happen. Now another question is maybe like to avoid an accident. What should these drivers do? So both of them should apply brakes. So that becomes another question. So we'll take it another time. Then it's another question. But what I told you in this video is this equation can be used relatively. Also, when you write V is equal to U plus AT, then you can also say V relative equals to U relative plus A relative into time. Now look here, if A in this equation when A is 0, then V is equal to U, right? When A is 0, then V is equal to U. So velocity is constant if acceleration is 0. Here if relative acceleration is 0, then relative velocity is constant. I am repeating. See, in these videos, just rewind it and see again and again, because we have very short term memory. Go back again, see, go back again 2-3 times, see this particular video. That is the beauty of online lectures. People say offline is good, but that is with online you can go on seeing it. What I am saying is, if A relative is 0, then V relative is equal to U relative. So you will ask me, sir, what is the importance of this? V relative is equal to U relative. It's very important. Just see. Suppose, now this question we are not dealing mathematically but physically. Suppose I throw this pen and then drop this. I throw this pen, black one, I throw and then I drop this. Now if I throw this pen with speed 10, suppose, whatever speed, 10 meters per second, and I drop it at the same time. So what will be their motion like in the time to come before they fall onto the ground? So you will say, sir, it's very confusing, how do I know? But this is very, very, very easy question. Why? Because even if you throw it with some speed and even if you drop it, after dropping, both of them are under gravity. Both of them are under gravity. That is G. So it has an acceleration G, it has an acceleration G. I am repeating, it has an acceleration G, it also has an acceleration G. If both of them have an acceleration G, what do you mean? So you clearly mean that if both of them have the same acceleration G, then their relative acceleration is 0. Why? Because A relative means A minus AB. Now this also G, this also G, relative acceleration is 0. Isn't it wonderful? Now if you write A relative is 0, that means V relative is equal to U relative. This happens in the case of gravity all the time. If you throw one object and drop another object, then their relative acceleration is 0, so relative velocity is constant. So suppose I drop it here with 0 speed, dropping means 0 speed, and this I throw it 10. So what is their relative velocity? What is their relative velocity? With respect to this, what is its velocity? 10 minus 0, because this is 0, this is 10. And this 10 minus 0 will remain constant. So any two objects thrown under gravity always have a constant relative velocity. So if you want to find distance after some time, simply you can multiply relative velocity with time. You can multiply relative velocity. For example, if it is 10 and he asks you the distance between two objects after 2 seconds, your answer should be 20. Now, haven't we done really fast without writing on board? We have done a question. Can you realize it? I dropped it with 0 speed and threw it with 10. What is the distance between them after 2 seconds? Now, this may be a confusing question, but with relative motion, it becomes very easy. Their relative acceleration is 0. How fast you throw it doesn't matter. You throw it with 100. But after that, its acceleration will be G, this also G. So relative acceleration. So they are not accelerated with respect to each other. If you throw it like this, you throw it down, still they are not accelerated with respect to each other, because once in air, they are under the impact of gravity, and gravity is secular. बहुत न्यूट्रल है ग्रेविटी, वो डिफ्रेंशिएट नहीं करती है हिंदू मुस्लिम सिख ईसाई, काला पेन नीला पेन, दोनों का एक्सीलेशन जी होगा, रिलेटिव एक्सीलेशन 0 होगा. जब ये 0 होगा तो रिलेटिव वेलोसिटी क्या हो जाएगी आपकी? कांस्टेंट. रिलेटिव वेलोसिटी विल बी कांस्टेंट. सो इफ यू थ्रो इट विथ 10, यू ड्रॉप इट विथ 0, so relative velocity is 10, it will remain 10 unless one of them strikes the ground. Now if the relative velocity is 10, then after 2 seconds the relative distance will be 10 into 2, that is 20 meters. Now if that height is not sufficient, if it strikes the ground, it's another matter. But if you throw from two buildings simultaneously, you throw it and you drop it, then you can say after 2 seconds the distance between them will be 20 meters. Damn easy, we have solved it even without writing anything on the board. So that is the power of relative motion and relative concepts. So this small video just of 20 minutes illustrates you the equation of motion with respect to relative motion. last class we just touched upon the basics. In two-dimensional motion also we can touch upon the relative motion, but that there we will have to use vectors actually. We will have to use vectors. But so much for now. Keep watching these videos, keep learning, and then we will have special sets on those problems. We just wait, maybe in coming 1-2 months, if you keep on watching, we'll start doing problems after problems, but in a way that you are able to understand it, not that I am solving it, but you are developing the capacity to think and find your own solutions. So thank you very much for now.